Hello all, we're going to take a look at the last section of Chapter 5. It's special systems of linear equations. So we have three different special systems that we can encounter when we're dealing with linear equations, systems of linear equations I should say, and solving. So on your foldable you should fold it in half so that you have the three sections on top, and we will start with this first section. So this section shows us a system of linear equations with one solution. So right here on the front, you're going to write one solution. Then you can flip it open, and we'll add some things inside. So here we go, one solution. On the top part of your foldable, when you open the door, you can just write what it is. It means that one solution at the set of ordered pairs where the two lines cross. That should be two lines. There we go. So this is what we've basically been looking at so far. We've been solving systems of linear equations. We've been getting a solution. So these are systems with one solution. So you'd solve it using any of your methods: graphing, substitution, elimination. Let's take a look at an example. You can write this on the bottom half of the inside of your door. So here's a system of linear equations: y equals 3x minus 5 and y equals negative x minus 1. So I'm going to go ahead and solve. Let me just scroll down for you. So the way that I solved this is our second step. The way that I solved this is by, by substituting y in my second equation. So I know that y is equal to 3x minus 5. So I replaced this y in the second equation with 3x minus 5. I solved it. I added x to both sides. I added 5 to both sides. I divided. I got x is equal to 1. So then I took that x value and I substituted it into my first equation. So I have y equals 3 times 1 minus 5. I simplified, I got y equals negative 2. So the solution to this system of linear equations is 1 comma negative 2. It has one solution. You can move to the middle door on your foldable. These are going to be systems of linear equations with no solution. So on the front you can write no solutions. Here's a graph, an example of a system of linear equations with no solutions. It has no solution because the two lines never intersect. So copy that down on the inside of your foldable. And we know that two lines that never intersect are going to be parallel lines. So let's take a look at an example. So here we have a system: 3x minus 2y equals 2, 3x minus 2y equals negative 2. I've chosen to use elimination to solve this system. So what I did, here's all my work. I took my second equation and I multiplied both sides by negative 1. So that gave me negative 3x plus 2y equals 2. And then here's my arrow showing that I rewrote my first equation and then I added them. So negative 3x plus 3x is 0. Positive 2y, negative 2y is 0. 2 plus 2 is 4. So I get 0 equals 4. And we know that 0 does not equal 4, so this is no solution. If I had rewritten my two equations, my original equations, in slope-intercept form, I'd get this, and you can see that both equations have the same slope but different y-intercepts. So because they have the same slope, we know that they're parallel, and because they have different y-intercepts, we know that they're not crossing at the same y-intercept. So they are indeed parallel. The final special systems of equations that we have are systems of equations with infinitely many solutions. So on the front of your last tab you can write infinitely many solutions, and on the inside you can write down the definition. So infinitely many solutions because the two lines are the same. Any x value will give you the same y value for both equations. So here's an example. This is the line for both of these equations. It is the same exact line, so there are infinitely many solutions. Can copy down the next example on the inside. So here we have 6x minus 3y equals 12 and y equals 2x minus 4. This time I've chosen to use the substitution method to solve. So I'm taking, since my second equation is already solved for y, I'm taking what the expression that it's equal to, 2x minus 4, and I'm replacing y in my first equation with that. So I get 6x minus 3 times the quantity 2x minus 4 equals 12. Distribute this negative 3, and I get 6x minus 6x plus 12, because negative 3 minus 4 is positive 12. When I do that, I combine my like terms. 6x minus 6x is 0. So I'm just left with 12 on this side, I'm left with 12 on this side. Since it is the same on both sides, we get infinitely many solutions. And if I had rewritten both of these in slope-intercept form, you could see that they are the same exact line. They have the same slope and the same y-intercept. So therefore, they are the same line and there are infinitely many solutions. So just to recap, we have three types of special systems of equations. We have systems with one solution. We have systems with no solutions. So in that case, they would have the same slope but different y-intercepts, so they are parallel lines. And then we would have systems with infinitely many solutions. They have the same slope and the same y-intercept, so they are the exact same line. If you need anything repeated, feel free to rewind the video, and when we come back the next day, we'll practice. Bye!